I'm back one more here. To finish on up, I was on the prostate. Well, I was talking about the sperm count and decrease in fertility in males. In fact, if we consider, I think the number's 125 or 100 million is considered low fertility or low sperm count. Anything below, I can't remember the number there. But we're actually considered sterile even if we produce a few million sperm, just because the potential of 50 to 100 making it to the ovum is so low. Anyway, I didn't get to finish the functions of the prostate there. So besides the nutrient material like fructose, the citrate, the fibrinogen-like proteins in the liquid material in the ejaculate, this is what the seminal vesicles and the prostate contribute. So the prostate right here at the base of the bladder, I think it's a pink structure here in this model that surrounds this, and the urethra runs right through the middle of the prostate, then entering the root, the shaft of the penis, and going out, exiting the glands there. Now, the prostate is kind of the Achilles heel in males. The statistic on this is 90% of us males, if we reach age 70 or greater, we will have problems with our prostate. And there's all kinds of problems that can occur. One of the most common is BPH, or benign prostatic hyperplasia, which hyperplasia is where we increase the number of cells to make the structure larger. Well, as you can imagine, if this prostate swells up and gets bigger on us, it tends to squeeze off the urethra that runs through the middle of it. So now it makes it very difficult for males and during micturition or urination. So this is usually a sure sign that something may be happening to the male's prostate. If they have to urinate, but they can't get much urine to come out, or what we call oligouria, maybe 100 mils or more coming out at a time. Those low levels of urine may be limited in their exiting because of the squeezing action on the urethra, because our prostate is getting large on us. The next structure right after the prostate here on the urethra, you can see a little round pink structure right here with a white tube connecting to the urethra right there within this area of the root of the penis. Now, this little gland, and it's actually two little glands on each side of the urethra, used to be known as Cowper's gland. Now we refer to that as the bulbourethral gland. And it is this gland here that has a couple major functions in male reproduction that are very important. Now, the Cowper's gland, or the bulbourethral gland, begins to produce a very clear, viscous, or really not more watery, I shouldn't say watery. It's compared to the liquid material, the ejaculate, it's a very viscous material. Viscous, the resistance to flow, so it have a low viscosity. But anyway, this thin, clear liquid begins to be expelled from the end of the urethra all over the glands of the penis. Now, as soon as the male starts getting sexually excited, this gland begins to produce its secretion. And so the secretion has really two major functions. Obviously, if you know this material already, you know that it has a very slick, lubricating quality to it. So as this material is secreted on the end of the penis, or the glands of the penis, it is going to allow then lubrication for entry into the female's vaginal canal. And with more of this lubricant, it of course obviously makes intercourse more pleasurable for both partners. The second function of the secretion from the bulbourethral gland is that it has to have an ability to counteract its other function. Remember from the urinary system, we talked about that the urethra's function is to expel urine out of the body. One of the things I failed to mention in that video is our urine ranges in pH about 5 to 6, normal for healthy urine. It actually can range from 4.5 to 8, but those are the extremes. Most people produce somewhere between about 5 and 6 on the pH scale. So we have this acidic material that has went through the urethra when we urinate. So before we have an ejaculation, it's very important that we neutralize the pH of that urethra. Because before we deliver these sperm through there, sperm are very vulnerable to pH. Acidic environments are toxic to them and kills them. So we need to neutralize the pH of the urethra prior to the ejaculation. So the second function, one being lubrication of the penis in preparation for intercourse, the second being it needs to neutralize this tube so that when the ejaculation does occur in the male, none of the sperm are killed on contact exiting the male's own body. Now, the same thing happens in the female's body because the vaginal canal is an acidic environment. One of the common bacteria there, lactobacillus, produce obviously lactic acid as a waste product, which makes the pH non-conducive to other living organisms like yeast and bacteria. And so this good bacteria that lives in the female's body also makes it very harsh for the male sperm. So this is another important reason for this fibrinogen-like proteins to keep it in a clump so that we have only the sperm that made contact with the wall of the vaginal canal died or are going to succumb to the pH factor. But all the rest are staying alive. And then as other things occur in the female's body, like one that we call vaginal sweating, it sounds wrong, but look it up in your textbooks. It's a legitimate explanation. There's no glands internally on the canal. So to basically have lubrication on the internal aspects, it's a transudation of tissue fluids through the canal wall that then help with neutralization and also with the swimming of the sperm onto their destination through the female's body. But that is the two functions of the bulbourethral gland. We will start next with female reproductive, but I think the phone battery's dead, and so I may have to wait till another day. You guys have a great day, and keep looking over your material for the final. Miss you. Bye.